Okay, let's go. Hi, my name is Tim. I'm the technical support and installation engineer at HRSoft. In today's webinar, we will have a look at how we can automate the creation of DXF and DWG files. With me today, I have Francois Simon, who will answer your questions, and you can use the chat box in the GoToWebinar panel for that. I'm going to make room after the session for more questions to let you follow this presentation better. We expect the webinar to take somewhere in the range of 25 minutes. The webinar will be recorded and it will be made available online later on. Okay, let's get started. So DXF and DWG files are really old file formats. They were born in 1982 as part of AutoCAD 1.0. Even today, these file types are industry standards when it comes to flattened sheet metal parts. A great number of applications like laser cutting software rely 100% on DXF or DWG files. If you have laser cutting or water jets or CNC routers, you know you need DXF or DWG files. And if you use subcontractors to take care of all your cutting needs, they most likely ask you to provide a DXF of the part you want them to make. So even in modern 3D Solidworks, we rely on 2D files. Getting one file flattened is no problem. Even file is no big deal in pure SolidWorks. But what if you have like 10 or 50 each day? How much time are then spent on manually creating these files? We can generate your DXF or DWG files from anywhere in SolidWorks. We can process single or multiple part files. We support single and multi-body files. We can automatically insert sheet in your drawing with the flattened part scaled 1:1 and all annotations removed. We can process a full assembly, searching for sheet metal parts, and from there create the required file output. Okay, live demo, and let's see how to automate the steps in the drawing environment. So I'm going to open up SolidWorks. And I'm going to open a drawing. Yeah, go ahead. So here is a drawing file, and I already prepared this beforehand. So if I go into my CustomTools folder, where this file is saved, I can then open it up over here. I can see that I have a document folder and then all of my part files and drawing files. So that's it. If I save this guy, then in my folder, I automatically created a DXF folder. And inside this one, I get actually 2 DXF files because I'm running a conversion rule during save. And actually, one of these are for the drawing and one of them is for the part. So one will rule out the other one. Let me open one of them. So this is C drawing, and if I measure this, I can see that this should be 60 millimeters across, and it is. So I got a DXF file created 1:1 with no effort at all. I'm going to delete these ones again. So what we are doing is actually we are making a DXF sheet. We could do this in pure SolidWorks manually. So we could insert a drawing view, we could remove all annotation, we could remove bend lines and notes, we could make sure that this was in 1:1, and we could remove the sheet format. And actually this is what I did on this one manually. So let's delete these 2 and just run a comparison on how we are doing this. So this is my file, and now in SolidWorks I want to create a clean sheet with the flattened file in. So I'm going to create a new sheet. I do not need the sheet format, so I will delete that. And then I'm going to insert a drawing view, the flat pattern, And you should actually count the steps while I'm doing this. So there is the flat pattern. Now I want to make sure that this is shown in 1-to-1. I don't want bent nodes in this. I don't want to have bent lines either, so I'm going to drill down and hide the bent lines. And then I don't want the center marks either. And if you are not aware, this is a little trick for you. If you select some entity in a drawing and you Control A, you will mark all of the center marks and you can delete those. So now I have my file created, or actually I have my file prepared for the DXF. Now I need to save it in Solidworks. So I don't know how many steps that was. It was like 16, I guess. In CustomTools, we created a button to automate all of this. It's called the CNC tool. If I press that one, everything that I just did would just happen automatically. So now I got the DXF sheet created. My file or my flat pattern is inserted. It's scaled 1-to-1. No bent lines, no nothing is inserted. And even the sheet format was deleted. But how did I then create the actual output? Well, for this one, I have a saving rule defined. So I'm going to go into the options. First off is the CNC tool, this button up here. This is configured using the CNC tool options. And in here I can define the name of the sheet to be created. So DXF sheet is that one. The paper size is kind of arbitrary. You can set it to anything you like. We just fit the boundaries to the shape required in any event. So set this as you see fit. But DXF sheet is the important one. You can call it anything you want, just make sure it's pretty unique for your DXF output files. Then in our file conversion, DXF from drawings is the one that I'm using for drawings, obviously. If I edit that one, I can see that I'm going to execute this rule each time a file is saved in Solidworks. So this rule applies to drawings. The drawing is going to be saved into this path, or the DXF is going to be saved into this path. So the original path of the file, then create a DXF folder if one does not exist already. The file name should be the drawing file name, underscore, the source configuration, material, and thickness. So this is how I am going to dictate my file name to look like. And all of these properties can be found in the context menu, where we can have any kind of model property inserted in the file name. We can have drawing properties or weldment properties. We can use a cut list item name, body number, source file name, path, configuration, and so on. And I'm going to explain this a bit more during the next part files and assemblies. But we can actually dictate our file name pretty robust using this. But what drives it only to take the DXF sheet? Well, from the drawing menu, we are only processing sheet if it is renamed or named DXF sheet. And that's it. So each time I press the save button on a drawing where we have a DXF sheet, we will automatically create a DXF file. That is pretty neat. If I don't want to run this on save operation, we of course have the option to run it from the print and convert, the batch conversion, and then select the DXF from drawing. It will do exactly the same, but on demand instead of each save. So the DXF from drawing will then select only the DXF sheet, and we can then process that one. And we got it. So just need to open the folder again, explore. And there it is, 1010, 1010. Okay, back to PowerPoint. Just a small recap. You should really stop wasting your time on manually inserting the flattened view. You can let CustomTools automate this process for a uniform result, so you always convey to your company default. If you have some crazy naming rules for your files, then you don't have to save anything manually. You can create the DXF during save or on batch, or you can do it both at the same time. The DXF master title is almost achieved already. So from parts, we can have a look in a live demo how to create from a part file, and this includes both single body and multi-body. So back to Solidworks. Okay, so I want to create a DXF from my part file directly, and I'm just going to use this one. But first I want to make sure that I have cleared the DXF output files in here. No one else? No. So in SolidWorks, you would go and right click on a surface and then export it. And again, you should really count how many steps there are in this one. So right mouse, export. You can get this type of SolidWorks question. I mean, we are clearly saving as a DXF. Why are we needing this one in the first place? So now I can save that as a DXF. If I had company rules for the file name, I would then have to type my company rule and then hit save. And then I need to select that this is sheet metal and then hit OK. And eventually hit save. So that's quite a bit of work just to create the DXF representation of this file. And let's see how it looks actually. Well, that's fine. I'm going to measure it. 60 millimeters. Perfect. But it took some time to create that, right? So let's do this CustomTools style. And again, really just count the steps. So I'm in CustomTools, but let's say that I was in features, just to add one more click. So that is 1, 2, 3, 4, 5. And now my DXF is going to be created following and obeying the company policy that I have set for saving this file. And even the save location was created because the DXF was just created now, this folder. So everything is just perfect as it should be. Let's analyze the file name for this one. So we have 1518. This is our part file name. Then we have default, which is our configuration. We have 1060 alloy, that is our material, and 6 millimeter. This is our sheet metal thickness. Then we have 555, and this is our cut list item name. And it's body number 1. And we are only using one instance of 1. So if this was a multi-body file, we could have several instances of the same file. And then I add just the time of the conversion. So we can really drive the file name to our company standards. I'm going to delete that again. And as for the drawing, I can also do this. So for my file conversion, in this case, the DXF part sheet metal, I can run this after file is saved in SolidWorks. So if the file I'm saving is a sheet metal file, this rule could automatically just apply. So I'm going to do like this, update that. And then when I save the file, it's going to create the DXF automated. So now if I open my Explorer again, I just recreated this one that I just deleted. So if it's a sheet metal, we will just run the conversion during save. But what if it's not a sheet metal? So I have a file here. It's not a sheet metal, but it really looks like one. If I'm going to save that, nothing is going to happen. I can save it and I can save it, and nothing is going to happen because we check if it's a sheet metal file or not. As soon as I convert this into a sheet metal file, actually let me do a copy of this one. So I'm going to save a copy and open that one. So still, it's not a sheet metal, right? I can save it and no DXF file is going to be created in the background. But if I insert bends for this one, then now it's a sheet metal. And if I save it, CustomTools will kick in and create the DXF file for it. And we didn't have to do anything. Okay. So let's move into multi-body files. I'm just going to close all of my documents and then open a multi-body file. Okay, so a simple part file, you would probably create one of these yourself if you are creating sheet metal files. I have a cut list containing 5 items. I have one bottom plate. I renamed these to be more saying for whoever is watching. So the bottom plate is the bottom, of course, and then I have 2 end caps and 2 sides. So I need, for my laser cutting department, to have 1 DXF per body in this one. So running Solidworks, I would have to do an export to DXF 5 times. And we just saw how that was done, and that takes quite a bit of time. If you watch the teaser video that we did, it actually takes around 4 minutes to complete that. And this is not even considering the naming rules completely. So yeah, it's a really time-consuming task. But with CustomTools, we can for sure automate this process. So for this one, I'm going to run a print and convert. In my batch conversion, I can run the DXF for parts again, and then just run the conversion. Now this is going to create 5 individual DXF files for me. It's going to add the instance and the quantity required, so everything is clear for whoever is going to operate the laser cutting machine. And it's all done. So I will explore back to my DXF folder, and these 5 guys were just created. So I have, if I compare it against my cut list over here. Come on. I have my 25 part, default size, AISI, thickness, and then I get the cut list item name, the side, 1 of 2, 2 of 2, the end, 1 of 2, 2 of 2, and then the bottom, 1 of 1. So I can easily open the bottom plate for this one. And there it is. And this is scaled, of course, 1:1. But what if I don't need to have individual bodies? I don't want to have 5 DXF files. Really, I only need 3, 1 for the end, 1 for the side, and 1 for the bottom. Well, it's just a matter of setting up your conversion rules. So if I'm going to run the print and convert again, I have defined another one for doing this. So that is a DXF export. And if I run this one, I will get a different result. So just let that run through. And now we got 3 DXF files, and this time I created them in the simple DXF folder. So if I open any one of these, for instance the end, then I get a node attached, and this is fully configurable, and you can define if you want this or you don't want this. But when you are doing these simple DXF files, whoever is going to receive this for processing would then require the bill of material as well. So just to rule out any confusion, we can add the quantity, for instance, in this one. And also we can provide the cutting length for the required profile in this case. So the cutting length times 2, and then anyone running the laser would know how much time that would take to do. Okay, so what if I really don't need 3? I just need 1 file. Print and convert. We can do a merged DXF. So I'm going to run this again. And when it's finished, I'm going to show you all of these settings in the options afterwards, because it makes more sense after you've seen what is going to happen. Okay, so now I got 1 DXF. In this case, it's saved to DXF merge location. And if I open that one up, I can see that I get 2 items of the side, I get 2 items of the end, and I get 1 item of the bottom. So really you can drive this to suit your needs for sure. I'm just going to delete all of these guys. So in the options, this is where everything is defined. I'm going to start with the nodes. The nodes are being defined in the database options under the custom nodes templates. And I'm using a node called laser cut info. The laser cut info is actually just a text and a link holder. So in this case, I have product, project number and name, and material and quantity. And to configure this is really easy. You just add your own, it could be demo, and then you can type in text down here. So that could be quantity. And then you just double click the quantity. Enter to create a new line, and you could call that material. And you link to material. Or it could be a model property designed by, and then look what we have of options in here. So drawn by. And really you can build this to suit your needs again. And this is going to be inserted if you want to in your DXF output files. So for the file conversion itself in the DXF export, this is one of the places where I use a node. We are driving the file type to be a DXF. This could be a DWG as well, wouldn't be any different. The conversion options, I am using display a custom node template to every view. So in this case, I'm adding the laser cut info node, but I could also use a drawing DXF template or web or whatever node I have created for this one. And that's about it. For the merge DXF in the conversion options, I'm going to have a look at my material and thickness. So I have put in a check mark that I want to create a file based on the sheet material part thickness and material, of course. So if I had different materials in my file, I would then create different files based on the material and the thickness. And then I'm placing a custom node again for these. Okay, so let me just make sure that I've cleaned out. I have. So again, just to recap, we can fully control the output from CustomTools. We can drive the saving location and build the required file name. We can even enable silent overwriting of files, and I didn't actually show you that, but I'm going to. For multi-body files, you just select the needed format of the file name and you get the result in no time. We can add body name or number, and we add the total quantity like 1 of 2, 2 of 2, for instance. If you want to, we can combine all into one file and add a note with quantity here. You are already a DXF master and you're not even done yet. So finally, I want to show how you can run DXF files straight from your Solidworks assemblies and in one single batch. And after this, you will be the ninja of DXF. So back in Solidworks, I'm going to close all of these files. And here is an assembly. So it's a really simple assembly. It's the same part as I just ran the conversion against, but in different configurations. So I have 2 default configurations. I have 2 small configurations, and then I have 1 large. Each of these part files contain 5 bodies. So 5 times 5 is 25 DXF files needed. In case I am going to create 1 by 1 by 1. So that would take like forever in Solidworks. If I had to do that manually, oh, I wouldn't even think about it. But print and convert can do that. So I'm going to batch convert DXF for parts. So even though we are in an assembly, we're going just to filter out and find the parts, which are all sheet metal, and then process those in the batch. So I'm going to run this conversion. And this is going to take maybe 1 minute, 1.5 minutes. But 1.5 minutes is nothing compared to the time it would take to do this manually in Solidworks. I guarantee you that. And we are just about there. So actually in the background, we are creating drawing files in a temp location and just deleting those afterwards because we don't really need them. But we are building everything in a drawing environment automated. So you are not going to waste any time on doing this yourself. But it's converted now. And if I open my Explorer view, I have my DXF location. And I have 25 files. So that was pretty lucky, I guess. I can see that the quantity is different now because some of these files are used more than once. So if I look at the small one, for instance, I know that I need, for one small part, I need 2 sides. So in this case, I have 2 small parts, which means I need 4 small sides. Okay. So if I find the small one, I have a side. I have 1, 2, 3, 4, or 4. So everything is just accurate and up to date based on whatever is in the assembly. What if I need to have 6 instances of the assembly? Well, you could create a temporary assembly if it's just for ordering purposes and just throw in your assembly 6 times. And then you could run the print and convert. We would know that we need to double or 6-double the quantity number in this case. And actually, let me insert, because if there is a non-sheet metal part in here, we're not going to process that. So I'm just going to find the number 22 again, insert that. This is not a sheet metal. So if I'm going to process it, it will not take this one into account. It would simply ignore it. And I can actually prove that really simple by running the print and convert. And not run this one. So now I'm only interested in running a DXF conversion against this file. As you may have guessed, this is not going to be converted because it's not a DXF file. So we ignore that completely. But there is a more easy way if you have a single assembly and you need to order 6 instances of it. So I'm going to close that one. And then from my my primary assembly, I can just run the print and convert again. Tell it to batch convert DXF part, but I want to have 6 instances of this one. So 6 times 25, that's 150 DXF files we need to create to our laser cutter. Okay, 150 files. Let's see how long it's going to take. I know that it would take more than 1 cup of coffee in Solidworks. But how long would it then take in CustomTools? Well, it's pretty simple actually. It would most likely take almost the same time as if you were converting 1 instance of the assembly, because all of this batch is going on in the background and the file operations are done, you could say, outside Solidworks. So if it takes 1 minute to convert 1 assembly, then 6 instances of that would take 1 minute and, I don't know, 5 seconds. But we're just going to let that run, and I can see there is a lot of questions. That is really positive. Can't wait to look at these after this session. And just as a side note, of course, you can run multiple batches as once. So in this case, I'm creating 150 individual DXF files. But I could also, during the same batch run, had selected to create a merge DXF, for instance. So I could really save a lot of time. Or I could create PDF files if those existed. And I could print everything. So in the print and convert dialog, you have a very nice tool. So now we are just about ready, I guess. Okay, so 150 DXF files created in at least less than 2 minutes. And there is the proof. And notice that the quantity now increased dramatically because we increased the quantity required in this assembly structure. So everything is accurate and up to date at all times. But there is one more thing that I would like to show, because this is a really nice functionality. Actually, let me just close everything. This is like a bonus information. In the print and convert dialog, if I open my DXF masterclass, this is what I've been working on during this session. I could add all of these directly by dragging and dropping into the window. I could even go in and select my documents and say, well, I have some Word files as well. So now I can print Word documents. I could batch convert to PDF, DXF, and you name it. So I don't even have to have a file open. I can just open the print and convert and drag files into this window and print them or convert them or whatever. And this is pretty useful if you have a bunch of PDF files you want to print, for instance. Then you can just do it like this. But I'm not going to run this. I'm not going to bother you with that. Okay, so a small recap again. You can process an entire assembly and sub-assemblies. You can define if you want merged DXF files where all parts are combined based on material thickness, or you could create individual DXF files for every single sheet metal component found, including the multi-bodies. The file name can be defined very flexible and you will always have the files that are up to date and accurate. The merged DXF, for instance, send that to a subcontractor with the files packed with information like the quantity used or the total cut length required per DXF, and you will have a quote back in no time. So that is all I had to show today. I hope you got inspired by this. CustomTools aim to remove all of the trivial items from the design job. Make sure that you stay tuned for more webinars and have a look at our YouTube channel for previous recordings. The next webinar is about creating the perfect Excel bill of material. I will now answer your questions if Francois not already did and stop the recording. So if you are leaving, I'd like to thank you and wish you all a great day.